to this lesson on rectilinear propagation of light. So we are going to look under the subheading reflection on plane mirrors. So to move ahead, it is important that we first of all understand what reflection of light is. Consider a light source which is placed in front of a plane mirror against a dark background. So the light source produces a ray of light which then bounces off on reaching the mirror surface. So what is reflection? So reflection is the bouncing off of light when it strikes a smooth surface. What are we going to learn in this video? One is a definition of terms used in plane mirrors. Two, we learn the laws of reflection. Three, we'll also learn the characteristics of images formed by plane mirrors. And four, we'll learn how to use ray diagrams to explain image formation by plane mirrors. So first, let's look at the definition of terms used in plane mirrors. So in the video you are going to see we have a mirror facing upwards, which we'll use to identify the terms. So we'll draw a line that is perpendicular to the mirror line. So this line is called the normal. So what is the normal? So normal is the perpendicular line to the reflecting surface at the point of incidence. Now, point of incidence is the point where the incident ray strikes the mirror. So consider an incident ray striking a mirror like that. So what is the incident ray? So incident ray is the light ray moving from the light source to the reflecting surface. Now, after striking the reflecting surface, the ray does not stop there. So it bounces off from the surface of the mirror. So what do we call this ray that bounces off? So this is the reflected ray. And how is it defined? So the reflected ray is the ray moving from the reflecting surface. Now let's look at more terms related to reflection on plane mirrors. So you'll now consider the angle labeled I. So we call this the angle of incidence. And by definition, the angle of incidence is the angle between the incident ray and the normal. Then we consider the next angle labeled R. So this is called the angle of reflection. So by definition, the angle of reflection is the angle between the reflected ray and the normal. Let us now consider the laws of reflection. So in doing this, consider the following diagrams. So first, look at the two angles 25 degrees and 25 degrees. Next, look at the two angles now 45 degrees and 45 degrees. Then 60 degrees and 60 degrees. What is common among them, considering the angle I and R? So you notice that angle I equals to angle R, and this is what constitutes the first law of reflection. The angle of incidence equals the angle of reflection. Let us now look at the second law of reflection, which states the incident ray, the normal, and the reflected ray at the point of incidence all lie in the same plane. You can now pause the video and attempt this short question here. So it reads as shown in the text there. Then we have the diagram. There is the ray XY, there is the ray YZ, there is the line WY, and of course we have the mirror line AB. So your task here is to basically identify the incident ray, reflected ray, and the normal, then work out the angle of reflection. So after reading this, pause the video, answer the questions, and then as a class you can share your answers and see what each person has. Now look at the following photograph. So you will see there is an object which has been put in front of a plane mirror, and that is enabling us to see the image of that object. Having looked at that photograph, it is now important to look at the characteristics of the images formed by plane mirrors. So you have a mirror line, then there is the object and the image behind the mirror. So the first characteristic of the image is that the object distance equals the image distance. Secondly, the image is laterally inverted. That is, the part that was appearing on the right hand side of the object now appears on the left hand side of the image. Next, the height of the image equals the height of the object. That is, image size equals to object size. In summary, the characteristics of images formed by plane mirrors are as follows. 1. The image is far behind the mirror as the object is in front, meaning image distance equals to object distance. 2. The image is laterally inverted. As you could see, the side that was appearing on the right hand side of the object, in the image it is appearing on the left hand side. Thirdly, the image is same size as the object. So we have used the height to demonstrate this in the diagram. Then the image is upright, just the way the object is. Then the image is virtual. as you are going to see, the image is formed by projections of rays but not actual rays. Having looked at the characteristics of the images formed by plane mirrors, now let's look at how we can use ray diagrams to explain the formation or location of these images and how they can be seen by an observer. So get your book, a pencil and a ruler, then let's move on. So first of all, draw a mirror as in the diagram, then the observer's eye, then we have an object in front of the mirror like that. So that is the object and this observer's eye. So after drawing this, we want to now locate the position of the image using the property that distance between the object and the mirror equals to the distance between the mirror and the image. So using your ruler, measure the two distances and mark as shown in the video. So that is the distance between the object and the mirror. Then the distance between the mirror and the image. Then we put the image at that point. So ensure that those lines are perpendicular to the mirror. Secondly, let's mark the point of reflection. Now to mark the point of reflection, we draw a line from the image to the upper part of the observer's eye, like that. So the point where that line meets the mirror is the point of reflection. So we will draw the incident ray from the object to the point of reflection like that. Then the reflected ray from the point of reflection to the observer's eye. After doing that, we repeat the same for the lower part of the observer's eye. So we draw a line from the image to the observer's eye like that using a ruler, followed by the incident ray from the object to the point of reflection, and then from the point of reflection to the observer's eye. And remember, when you draw rays of light, always use arrows to show the direction in which light is moving. And you'll see from the diagram, light moves from the object to the reflecting surface and then from the reflecting surface to the eye.